Okay. Wow. All right. Hey guys, how's it going? I hope your spring break went well. We're going to be continuing our Python lectures with week 4, and today's lecture is going to be pretty brief. There's going to be a little introduction to object-oriented programming, and I'm also going to give you guys an assignment if you'd like to work on it on your own time. It's going to be a little blackjack program. So basically, where we left off last time was functions, and we're going to get into classes today, which is kind of like the backbone of the whole concept of object-oriented programming. It's being able to make your own custom objects. So from the little write down over here, we can see these are basically all the things we're going to be going over today. So objects, using the class keyword, creating class attributes, creating methods in a class, and methods are basically functions that are housed within the class. We're going to be learning about inheritance and special methods for classes. So over here, there's a quick brief reminder on what objects are. And in Python, pretty much everything is an object. So this list over here from week 1 when we covered lists, so the list itself is an object. And if you remember, we could call specific methods on lists that are native to Python. So for example, count would be one of them. And this would basically count how many times the number 2 appears in that list. So that would be a built-in method for this object, which is a list. So over here we could see that all these different types are actually objects. So we have integers, lists, tuples, dictionaries. These are all different types of objects. And Python has a lot of native objects within itself, but we can also customize objects using classes. So over here we can see that the little template for creating a class is fairly simple. We basically just start with the keyword class, followed by the name that we want to use for that specific class, which would be a general case that would kind of apply for every specific object within the class. And then we just have a little object keyword over here. And right now this class is currently empty. It's just a pass statement, so it's not really doing anything. And this would be an instance of where we use the assignment operator to create a new object, a custom object from our class template that we created. And when we print out the type of X, we could see that over here it's of type sample, which is a custom object type that we created. By convention over here, as it says, we give classes a name that start with a capital letter, and we could see how X is now referencing our new sample class. This would be what's called instantiating the sample class. Inside, there isn't much right now, but as we slowly add things in, there's two main different things that we're going to be having within the classes. It's the attributes, which is a characteristic of a specific object. So we can basically customize this object with as many different attributes as we'd like. And also methods. So methods are going to be functions that basically perform operations on that specific object. Over here, there's a brief example. So creating a class called dog, and attributes for a dog, I mean, there's a bunch of different things. So breed is probably the simplest one to go with, or its name. And then over here, there's a method created called bark, which is something that, it's a function that dogs will often carry out. So when creating attributes, there's a special method that we need to actually make sure to use first and create first. And it's this init method, which is basically the initialization method, or in C++ it's referred to as the constructor. And the syntax for this is specifically has 2 underscores in the beginning and the end, and it's init followed by 2 brackets. And within this function, so this is a function, so we just basically define it like we would any other function, def followed by this specific name. And you can't really name this whatever you like. It's very specific, so this is the format for what it is. And then it's followed by a self, which is basically referencing that specific object, and this is kind of all just the form that which it goes. And then after this point is when you actually pass it the arguments. So if I wanted more things over here, I could have breed, height, hair length, like etc. And once we create this function, within it, what we do is we initialize all of the specific attributes that have to relate to that specific object. So the breakdown of how this would go is, like, let's say if I had 2 arguments in here, I would have 2 separate attributes titled self.breed equals this breed over here that we pass into the argument, and self dot whatever else my argument would be. So there's a little bit of a breakdown as to how this would work. We create the class, and then these 2 instances over here are where we're creating separate custom objects that are of type dog. So we would have Sam, and then assignment operator, and then over here, this line over here says, okay, so dog is, we're referencing the class dog, and in here for the argument, for the attribute breed, we're going to specify it to be the string lab, so it tells us what type it is. And for this, the dog named Frank, we would initialize the attribute of the breed, in this case to be husky. And how this works is, first when it's created, the initialization function is called. So first we see this, and what happens is the arguments that you pass within when you call the actual class itself, right here, they get placed into the arguments within the initialization function. So self is just an argument that references to that specific object. So you don't need to pass a parameter for self when creating a new object. You're just going to have to pass everything after that specific argument. So in this case, we only have one argument, the breed. So when we create a new dog object, we have to specify what type of breed. What you can also do is you can set a default for these attributes. So if I really wanted to, I could set breed equals lab over here. And what that would do is, if that specific attribute isn't provided when that object is created, it would default to whatever I give it in the initialization. So we'll go over a quick example of what I mean. So if I were to create a class dog, over here, I can initialize this breed to lab. So now if over here, let's say I create Sam the dog, I'm going to give it a capital name because I think it deserved it, dog, and if I don't actually pass it the breed argument, it will default to lab. This won't happen if I don't actually set the default argument. So if I don't put any default argument over here and I just leave breed, this actually isn't going to work because it doesn't have information for this attribute. So it would only work in the case where I actually set the default over here. In most cases, if let's say we're dealing with number values, we'll go over some examples of it later, but some attributes are useful to initialize with a default. Other times you don't necessarily want to because of the different variety that you might get with those specific attributes. So moving on, we've created 2 instances of the dog class, and when we actually call the specific attribute within that class, we can see specifically what it is. So over here, I create Sam is equal to the dog, and the breed is equal to lab. And let's, for the sake of saving typing time, come over here and make this guy. Now when I print, let's say, sam.breed, what this is going to do is it's going to return to me the specific attribute associated with Sam, right, which will give us lab. And notice how there is no parentheses after breed, because breed actually isn't a method, it's an attribute. So think of it as kind of like it's holding a piece of data within it. Now, there are also, as it says here, class attributes. So these are attributes that would be more general in nature and wouldn't necessarily be changed within a class itself. So the example here is a pretty good way to describe it. All dogs are mammals, right? So if we create an object attribute species, which we would declare before the initialization, it would be at the top of the class. We would say species is equal to mammal. And now this creates a object attribute that is associated to every single object of this type. So any dog that we end up creating, if we call this specific attribute species, it's going to be a mammal. And this is generally something that's not going to be changing too often. Right, so we could also, as I was saying, if we add a new argument here, name, for example, then we can actually store the name of the dog as an attribute within the object. So self.name would be equals to name. And now over here, I would pass name. Now if I print the name, right, okay, so what I forgot to do is to specify to which I'm referring to in terms of here. Let's see what the issue is. Line 10. Oh, yeah, okay, so that's actually not the problem. I'm just forgetting to see, because I created a second attribute name and I set it for this object, but for this object there's only one argument passed. So it's basically not given enough information. So Frank. And when I print the name of Sam, see we have right here. And these things generally go in order. So if the order of the arguments given in the initialization is as follows, breed followed by name, it would be passed within the same order when you actually create an object of that type. So now we're going into methods. Methods are functions that are defined within the body of the class, and they're used to perform operations for that specific object type, so within that class. These are very important in terms of object-oriented programming in general. It kind of, the purpose is to kind of divide up the amount of work that is happening within your program into more manageable and more approachable and cleaner segments. So over here is a nice example. We have a class circle, and I'm going to actually do things a little bit differently than how this example is done. I'm actually going to import the module NumPy because it has a lot of pretty useful mathematical features, including a more accurate value of pi than 3.14. Also, another easy way to get a more accurate value for pi, this doesn't necessarily have to do with this, but if I import NumPy and I have inverse trig, I don't know if you guys have experienced any like inverse trigonometric functions. Basically, the tangent of pi over 4 will give you an argument, will give you a return of 1. So it's a 45-degree angle. The x and y are both the same, so the tangent for cosine over sine is just the same value, so you get a 1. So if I take the inverse of that, so if I have the inverse tangent of 1 and I multiply that by 4, what I'll be getting is actually the value for pi in radians. So that can be done, like this, 4 times p dot. I'm going to actually look up the specific. So this is a really useful website, scipy.org website. They have a lot of great libraries that can really help you specify what it is that you'd like to do. So this is what I'm going to be using, arctangent. And basically the docs are very detailed. There's a lot of far more advanced functions that you can use using NumPy, a lot of like linear algebra libraries as well. But just for the sake of simplicity, we're actually going to use np.py, which I believe will get the job done. Right, I guess I'm not remembering the exact way for which to use it, so I guess for now we won't worry about that. So back to the class, circle. Oh, there we go, okay. It just took a little while to load. So it does work, we have a much more accurate value for pi. So I'll actually leave that there. We're going to set pi to np.py. And basically what I'm doing with this is I import the NumPy library as a shortcut, just np. So every time I'm referencing it, I don't have to actually type out the entire name of the library. Now, there's there's only one specific type of information for any given circle that has to be given. That's the radius size. So if I'm creating a class of circles and I want to initialize it, I really only have to create one attribute, and that would be you always have to pass the self, which is referencing the specific object, and radius. Now I'm going to set the default radius to 1. So if the argument isn't given and just a circle object is created without any arguments, it's just going to default to 1. And that is pretty much a very simple initialization for any circle object. Then we have a couple other functions here. So the area, which would basically return the radius times pi, which is pi r squared. Then we would have a separate method for if we want to actually change the radius of that specific object. So let's say we have a circle of radius 1. Instead of creating a new object which is a circle of a different radius, we just change the existing radius for the circle. And we also have a function that prints out the radius of the circle to us. So a lot of times within programming, you don't want to be actually, if you're trying to get the information of a specific attribute, instead of calling that specific attribute, what you'll have is you'll have methods within the function, within the class that return that specific attribute. So instead of just for example getting my circle dot radius, I'd have a function called getRadius, which basically returns that value. So kind of works in the same way as how in C++ when you have private variables within a class, and in this case you do have access to it, but in C++ you actually don't have access to private variables outside of that function's class's scope. So you would have to create functions within that class that would return those specific private variables. So it's kind of like the same concept, and it helps keep your work a little bit more organized. So I'm not actually going to type all this stuff out. It's pretty straightforward. So area, radius, returning the radius, and so I'm going to go over inheritance. And what inheritance is a way of making new classes using existing classes that you already have. There's a couple terms within this that it's helpful to keep in mind. So when you use a class to create a new class, what you're essentially doing is you're saving yourself the work of having to write the same thing twice. Let's say if they have similar methods or attributes between the two separate classes, instead of writing all that code twice, you can just reference it, and we'll go over it right now. But basically the classes that you're going to be using to start with are called the base classes, and any class you use that base class to make is going to be called a derived class. Also, descendants and ancestors is a good way to think about it. So over here, as we can see from our previous example of the dog class, we're going to make a base class for the dog class, and we're going to call it an animal class, right? So class animal object. We have an initialization, and basically these functions are just containing print statements now, just so you can see kind of the flow of what the program is doing. So in this initialization, we just have it printing the statement animal created. And for these other methods, so who am I would be printing an animal, and eating would be just printing eating, just for the sake of getting it conceptually. And then for the dog class, within the initialization method, what we're actually doing is we pass animal into the object parameter for this class. So we know to reference that class when dealing with specifics inside of this derived class. So within our initialization, what we would do is we would call the animal object initializer, and we would basically inherit all of the attributes and methods from within the animal class and place them into this new dog object that we created. But in this specific case, for the initialization for the dog, we're going to be printing dog created. So actually it'll be printing both statements when we create a dog. First, it will run through this process when this is called. So we will create the dog, it will go into the initialization method, and it will call the initialization method from the animal class. So we're going to get this printed first, followed by this print statement. Now, when we have a dog, and we have a similar method called who am I, does a good job of clarifying that the priority in terms of which methods to reference definitely comes down to, for example, if I create a dog class and the base class is animal, it's going to be referencing the method within the dog class. So over here, when we create the dog, t equals dog, the initialization fires, we print both these statements. And then when we call this function, it's not actually referencing the function in the animal class, it's referencing the function in the dog class, because that's the type of object that we created. However, when we call the eat method, which isn't present anywhere within this block of code for the dog class, it knows to reference the animal class, eating. So kind of think about it. And for example, we can add to it. So if we want to keep all the similarities of an animal, but we want to add specifics that would be unique to a dog, for example, like barking. So all animals eat, but not all animals bark. So we would be able to add a specific method to the dog class that kind of adds on to the functionality of the animal class. So We're going to go over what's happening here. So the dog object is created as just D. Both of the initializers are fired. When we call this method, it references the method within the dog class. And when we call methods that are present in the base class, the animal class, they're still present within this object, and followed by new methods that we write. All right, so the derived, over here as it says, the derived class inherits the functionality of the base class. The derived class modifies existing behavior of the base class as well. So those are two useful features of inheritance. And the last thing we're going to be going over are special methods. And we've seen things like this when we're talking about built-in methods for some of our previous objects. And these aren't actually called using the direct name that you give the functions. They kind of work in the same way as the initialization function, and they reference specific Python syntax. So over here in this example, we have a book class, and in our initialization, we give it three separate arguments. We have the title, the author, and the pages. And we also have a quick little print statement just to show that the initialization is called every time we create a new object, followed by the appropriate attribute initializations. Now over here, as we can see, we have an str with 2 underscores as a name for this method. And what this does is when you call the print statement on a specific custom object, it might not know exactly how to handle it. So in most cases, if you don't have this specific function in here, what you're going to be getting is probably just the object type. And sometimes you want a brief description of what the object is or what the object contains, like the attributes. So you could do this using this special method over here. You would just pass self to it just like anything else. And in this case, it would return a string, hence the str, that would be composed of the title, the author, and the pages. So it would be a string of the attributes of that specific object. We also have the len, which references this specific function that we know about already. And in this case, if we're asking for the length of a book, more likely we're asking for the number of pages. So this would return just the number of pages. We also have the del function, which basically deletes this object. This would be handy if you're working with limited memory space and you don't necessarily want to hang on to things that you're not using anymore. So the example of how these things would be used is over here we create a book object from the book class. We would have the title be Python rocks, followed by the name of the author and the number of pages. When we call the print function on this book, it's going to reference this special method, the str method, and it's going to print to us what we give it in the return statement over here, which is a string, a formatted string that will give us all the attributes. So it would be the title, author, and the number of pages. Then if we print the length function called on that book, in most cases, if you have a custom object, it won't work if you just call the length on it, because it wouldn't know exactly which attribute you're referencing. So if you give it a specific attribute to reference, then this function will work on it because of this method over here. And it'll actually return to you the number of pages because that's what you told it to return. And over here also the delete function would print, what you give it, but more importantly, it would actually delete the object. So the delete, I believe, works on native Python objects as well, but you have to specify for custom objects. Now that's it for the lecture part. It was kind of just a brief introduction for object-oriented programming and how classes operate. I do have a quick little set of examples that I would like you guys to try. You can find them right over here. And basically there are 2 classes, one for a line and one for a cylinder. And basically, I just want you guys to write quick little methods for computing the distance and the slope for a line and the volume and surface area for a cylinder, so you guys kind of get a hang for what it is. The math part of it is relatively simple, but just so you can kind of get understanding for the flow. And also, I want to give you guys this assignment that will kind of be using everything that we've been doing up until this point, especially with classes and functions. And what it is a blackjack game. So I don't know if any of you guys have played blackjack before. There's a link over here that can reference you to the specific rules of the game. But next week in the beginning of my lecture, I'm actually going to go over the solution to this problem, which is not too complicated, but it is a fair amount of code. So I just figured it would be a really good practice for you guys to try to see how you can approach this problem. It's going to involve multiple different classes and a few functions. So some classes that you might want to consider using would be a cards class. What this would do is basically hold attributes for one specific card, being the suit and the actual number value. So you would have the ace and then 2 all the way through 10, and the jack, queen, and the king. It would probably be easier to set some global variables, such as a list for suits. How I'd probably go about this is create a list, and my 4 suits would be hearts, diamonds, clubs, and spades. And let's see, for numbers, it would be something like A, 1, 2, and etc. You also might want to make a dictionary to actually store the values of these strings, because these are ultimately strings. Like this 1 and 2, they're string values, they're not actual number values. So you would probably want to make a dictionary for storing the actual values for these points. And the only tricky one is going to be the ace. So in blackjack, if you don't know, aces count as 11 points, but if you exceed the 21 point margin, then they only count as 1. So you would have to kind of take that into consideration throughout your code. But some classes that would probably help with this would be, like I said, a cards class, followed by a deck class, which, just off the top of my head, some of the methods for this class would be to initialize the deck with all, I believe, it's like 52 cards, followed by a quick shuffle function. The random library in Python actually has a shuffle function, so you guys don't even have to worry about working too hard on that aspect of it. And then ultimately you want a hand function, hand class, which kind of the attributes of that class would be, the total number of cards in your hand, their total value combined. The other functions like hitting or passing, those kinds of things would probably you wouldn't necessarily find their way into those classes. They would just be functions in the program itself. But yeah, if you guys have any questions about this, like I said, we're going to be going over the actual solution to this next week. But if you guys have any questions, I can drop my email on the board and just feel free to let me know. But I think that's going to be it for today. Thank you.